Welcome to another statistical class. Of course, today we're starting a new chapter that we call probability. I want everyone to pay attention, listening, because this is a topic that I believe scares most of the students. But I'm actually gonna make sure I relate every notation, equation to real life. So I welcome you to today's class, probability in everyday life. In the outline, I'm going to introduce you to probability, discuss some concept. Then I'm actually going to explain the role probability play in statistical inference. Then I'm also going to touch down on models for random phenomena. Then basic probability terms, then set operations on events. Okay, so let me first have a kind of recap why we find ourselves doing what we're doing right now. The whole story started from the fact that we're trying to understand our environment, okay, because of the variations in the environment, because different things happens in different days, because of the multi-state environment that we find ourselves. Then we realize living in a stochastic environment is synonymous with living in a probability space. So it means we live in a probability space because of variations. Now, understanding the environment that is probabilistic in nature requires probability knowledge. I'm going to say that again. Understanding environment that is probabilistic in nature requires probability knowledge. And that is the reason why we are here learning about probability. I'm going to say that probability is a measure of likelihood occurrence of an event. I'm going to say that again. Probability is a measure of likelihood occurrence of an event. Now, let me tell you this, a lot of activity, okay, in our daily life that are probabilistic. And somebody investor normally has some questions in mind. Should I invest in stock market or not? Why is it so scared? Okay, why not going to the market? Because of the fact that there's variations in the market. So for you to be able to invest, you need information about a market that is stochastic in terms of what it brings. At times, you ask yourself whether you should get collision insurance on my car. Okay, if you get it and accident happen, you've taken the right decision. If you don't get it, an accident happen, of course, that would be too risky. So, should I start a business? My wife is into cosmetic business, and before she started business, she was asking a lot of questions. She wanted me to use my statistical knowledge to be able to see on average whether she's going to have returns. I want to believe she was asking that question because she knew we live in a stochastic environment. So we face even decisions such as whether or not to carry an umbrella with you in case it rains, because it's probabilistic. It's either it rains or not. You know, when you go from industry to industries, whether you want to talk about insurance remain in business because of the fact that they're using the knowledge of probability to figure how the chance of their customers, making a claim. Okay, in medical diagnosis, the idea of probability is used. At times somebody is in hospital, and after diagnosis, the doctor is going to come out with a statistical statement. Could say, oh, 60-40. He arrived at that because of the fact that there's an uncertainty. So the knowledge of probability will enable us to understand our environment, because the environment is probabilistic. Therefore, it requires us to have probability knowledge for us to be able to secure the environment. Okay, now probability is a model for random phenomena. When you collect your data, okay, when you have your data set, there's a lot of randomness in the data. And the statistical models that we apply are probabilistic models. I'm going to say that again. Statistical models that we applied are probabilistic models. Okay? So when we're talking about, because of that, I'm actually going to go into phenomena. We got some phenomena that are deterministic. We got some phenomena that are not deterministic. In your high school, you've seen some laws in physics, chemistry. I remember the Isaac Newton law of motion in physics. The first law, the second law, the third law, all are classified as deterministic models. Why deterministic model? Because there's no randomness. Because when the formula will give you exactness, it's going to give you exact characterization. When you put an input, a number input, it's going to generate this, that same output. If anybody put the same input, you're going to have the same output. Okay, if you want to talk about the force, where that is equal to mass times acceleration. If you know the mass of a body, you know the acceleration of a body. If you multiply that, you get a force in Newton. Those are deterministic models. They are not subject to variation. Okay? So mathematical models are deterministic models. 5 plus 2 in United States is 5 plus 2 anywhere in the world. That is deterministic, not subject to variation. But when we talk about non-deterministic, we're trying to say, an event that cannot be predicted exactly. That's what we mean. It's subject to variation. We got some form of randomness in it. And that is what make them non-deterministic. Statistical models are not deterministic. Okay? So non-deterministic, it means, even though you cannot exactly determine the occurrence of the event, but we can actually assign probability to the occurrence. And that is the reason why. And the reason why, I'm going to tell you this. In the deterministic model, we have a control on all variables. In deterministic, we have the control on all variables. But in non-deterministic, we do not have control on all variables. And that is the reason why if a weather forecaster is actually, they normally say, okay, there is 60% chance of rain tomorrow. Why is it that he didn't say there is 100% chance of rain? Because of the fact that he was not able to control all variables that has to do with the atmospheric condition. And that is the reason why it's actually giving you that prediction, not exact prediction. Okay, I just wanted to take note of that. I think I've already given you some form of deterministic phenomena, what you observe in physics, in chemistry, in exact sciences. Why do they call them exact sciences. Okay, you know, when you use this input and that input, if anybody use the same input and that input, is going to give you the same output. It is not subject to variation. You know, we got some situation where we use them, okay, and we got some situation where we don't use them. Okay, when you know, situation where we got control over variables, all variables, of course, we can go deterministic. But if we do not have controls over all variables, okay, situation where we don't have control is when you have a complicated situation, which is the one that we experience in everyday world. We're actually going to use a non-deterministic model. Okay. Now, when we talk about a non-deterministic model, of course, we actually have what I call, the random phenomenon and alpha phenomenon when it comes to non-deterministic phenomenon. Okay, the random phenomenon, initially we are unable to predict the outcome, but on the long run, okay, we believe that when we look at the trend, it's what I call statistical regularity, okay, and we're able to predict on the long run, okay. So that is why statistics, what we do is to make prediction under uncertainty. We make prediction under uncertainty, okay, in statistics. Okay, when we talk about alphasad phenomenon, the alphasad phenomenon is there, when events occur in a completely disorganized manner, completely unpredictable manner. Imagine somebody is driving, not you. Somebody is driving, and a car in the front stops suddenly, and when we're on the highway, maybe like 65 or 70, that's going to be dangerous. I'm actually going to call them a sporadic events that be classified under alphasad phenomenon. Okay, it's not an event that one can actually predict even on the long run. But let me tell you this, that is why we're advancing our research in statistics to make sure that we also can have that kind of prediction. Okay, I said unpredictable outcome, but no long, okay, exhibition of statistical regularity. Okay, go ahead. Yeah, when you talk about phenomena is divided into two: deterministic, non-deterministic. So right now we are on non-deterministic. Does that make sense? Okay. Now, and this is it. This is a clear picture. Phenomena divided into deterministic and non-deterministic, and the non-deterministic also divide into as alphasad and random. Okay. Now, I think I've talked about the alphasad. I've talked about random. Now, you now understand a random, a random phenomenon and a non-random phenomenon. Now we want to go into basic terminologies in probability. Okay, so now I need you to pay attention. When you understand what is behind the scene, you're actually going to be fine. Okay, statistics, probability is the most simplest topic in statistics, but I need you to pay attention. Now, let's have some definition. Experiments. You do not need to be, I can see some students watching on their phone. If you are, I'm not going to point to the students. Okay, I needed to pay attention. Some students are watching something on the phone. I needed to pay attention. You pay for the service. I can see them now. If you are the student, you are watching on the phone with your friend, two of you watching on the phone. So I needed to call in the United States is very, very expensive. You have to justify why you are here. Okay, now experiments. You don't need to be in the physics lab or chemistry lab to perform experiments. Okay? Then what is an experiment? Experiment is a trial that generates an outcome. Any trial, anything you do that generates an outcome is what we call experiment. Okay? If you write exam, there's going to be an outcome. Okay? Somebody could pass, somebody could fail. Okay? So I just wanted to know, in a probabilistic world, okay, why do we, because of the fact that we have different outcome, variations in outcome, and that is the reason why the world become probabilistic in nature. Imagine we have the same outcome. I remember one of my daughters asked me a lot of questions. Why do we cry? Why this? Why that? But I told them I don't know why, but they are more or less like part of life. But I don't know why that happened. But when they happen, how can we manage them? Or how can we try and prevent them? It's just like you are a student now. You're going to write exam. You need to be able to put all necessary machinery in place to make sure you excel. But don't forget, in this, there's also possibility of failure. Does that make sense? It is the stochastic world we find ourselves. So experiment will lead to an outcome that may be favorable or not. Then what do we mean by event? Event, okay, is a particular outcome in an experiment. It could be favorable, it could be unfavorable. Of course, we all want favorable one, but we should have it at the back of our mind. Unfavorable one also occur. Now, random experiments. What do I mean random experiments? Okay, a random experiment is an experiment that you perform repeatedly under the same condition, but give different results. Look at that. You perform an experiment. Okay, if you go to a factory where workers are working, okay, what the number of item they produce on Monday may be different for what they produce on Tuesday, even though the machine is working great. That is what I'm going to call an inherent randomness, that is on the system. No matter what we do, there's going to be variation. So random experiment is when you perform experiment repeatedly and that turn out different results at different trial. Does that make sense? Okay. Now, I want to go into an example now. Okay, performing an experiment, I take a coin. A coin has two sides. Let me tell you this. If you want to understand the stochastic environment, then you need the knowledge of totality. I'm going to say that again. If you really want to understand probability, you need the knowledge of totality to be able to understand probability. Totality is possibility, the possible things that can happen. A student writing exam, a possible event is either the student pass or fail. A business person, there a record profit or loss. A politician seeking for a position, elected position, is either he or she wins an election or loses an election. They are all aware of that. Now, I actually want to play with a coin, a fair coin that has two sides. S means sample space. Okay, sample space is the collection of possibility. When I just say coin once, I'm trying to tell the world it's either I see head or tail. That is what I mean. Go ahead. Is that what? Yeah, we like for this class. If I wanted to define a sample space, the notation is X. Do you see that X? Now I'm writing it as as a set right now. Like inside the sample space, I got head tail. So which means if I toss a coin once, I got two possibilities. Even though it is only one that will show up when I go for election, what is going to happen? It's either I win or lose. One event will but before going for election, I know possibility. Okay, now, unable to predict on these toes whether it's head. Like if you take a coin now, you may not, you may not be able to know the one that will show, but all what you know possibility. Okay, but let me tell you this: on the long run, when you have a repeated trial, I just talk about repeated experiment, right? Random experiment, right? I chose maybe head, it may be tail, it may be tail. I'm getting different thing at different trial. I'm choosing it the same way, but you know what? On the long run, the percentage of head will be the same as the percentage of tail. If you get home, if you do it 10 times, that may not hold. You may see 7 head. But if you do it repeatedly, and that is the reason why in statistics we encourage large sample. Does that make sense? So that is what we mean on the long run. Okay. Now, what if you work with die? A die has 6 sides. Okay. And of course, on the long run, the probability of each of them showing up is 1/6 because we got 6 sides. Don't forget, that was what we said on Monday when we're working on sampling technique called simple random sampling, where if I have 1,000 individuals, okay, and I want to choose from them, I'm actually going to give them equal chance. The probability of choosing one person is 1 out of the totality. Does that make sense? That's exactly what we mean. But at times, what if we're not interested in tossing a die once? At times we may have 2 dice and we toss it once. Then we need to be able to understand possibility. I could have 1, 2, and so on up to 6s. I need to have the knowledge. This is what I'm having here is stating the sample space, which is a collection of possibility. And because of that, I need to, so which means if you want to answer any probability question, ask yourself, what is the sample space? If you don't understand sample space, then you may not be able to have that, that computed correctly. Okay, sample space is a collection of possibility. What can happen? Okay. Now the sample space can, a sample space we can have a situation where there's no limit to the numbers of elements we have. If you take a look at what we have right now, 1, 2, 3, 4, 5, that is taking forever. Okay, so we can have that. Okay, now in the summary, tossing a coin, the sample space is that tossing a coin once, tossing a die once. Okay, I can use numbers instead of using this. I can use numbers 1, 2, 3, 4, 5, 6. And even here, head and tail, I can use number as well. But this is the way we normally do it. Okay, we can assign to 1, 0. We can use 0, 1 when you have, because that is categorical, right? That's categorical, binary, 2 levels, right? I can assign 0 to 1 and 1 to the other one. And let me tell you this: assigning numbers to this, assigning numbers to elements in the sample space, that is actually called random variable. I'm going to say that again. Assigning numbers to elements in the sample space, we call that random variable. Okay, now, is your time. And you know what? If I want to assign numbers to this, then it's going to become this. Don't be scared. You see that now? We just assign numbers. Oh my God. The numbers here is looking like a coordinate. You've heard about coordinates in high school, X and Y. Okay, that was why you see here, X, Y. Okay, I'm actually going to call the first number X, the second number Y. Okay, and that's why you see the value showing on die 1, I'm going to call that X. The value showing on die 2, I'm going to call that Y. What am I trying to say? There's a variation in die 1. There's also variation in die 2. That's what I mean. You know, mathematically related subject is the most simplest in the whole world. Most simplest subject. Why? When you pay more attention to what is behind in every notations, every process, mathematical process, they are actually, they have information they are passing across. I want to move right now. I want to go into events. And what I'm going to be doing now, I'm actually going to adopt what Venn, or we got a mathematician. If you really want to understand set, if you want to understand probability, if you want to understand event, okay, Venn actually introduced what I call a Venn diagram, okay. It's going to be rectangular in shape. The whole area in the rectangular shape will be called sample space. Okay, now the area that is shaded right now is a particular event. We are not interested in all events in the sample space. I told you the other time, okay, in a sample space, we got some events that are favorable. We got some events that are not favorable. Okay, right now, event E is a subset of the sample space. Okay, that is a way to show that mathematically. Okay, so and let me also tell you this. If I toss two dice once and I know possibility, I may not be interested in all of that. Maybe I actually go on a bet with somebody. I will say, okay, we know we're going to play two dice now, and whoever that see a total of 7 will win. Okay, now I'm actually going to go into this possibility. A total of 7 is 1 6 see that diagonal, right? Okay, and that is what I write out. Okay, we call that event. Event is a subset of a sample space. And you know what we're gonna be looking for, right? Maybe we want to find the probability of having a total of 7. If I want to get the probability of having a total of 7, then I need to know what is the number of 7 and divided by the number of totality. Okay, so right now 1 2 3 4 5 6, and which is going to be 6 divided by the cardinality of the sample space, which is going to be 36 in this case. Does that make sense? Okay, now I want to go to special events, and I need you to pay attention. We're going to be using some notations now. Okay, now when we talk about empty sets or a non-set, okay, we actually use this notation for that, and we're going to write that equal to that. We're talking about a set that contains no element. If it contains no element, then the probability associated with that will be 0. Okay, but let me tell you this. If you take a look at this two now, empty events, we believe event that never occurs, but the sample space, which is the entire event, is always going to occur. And because of that, we call that sure events. It's a sure event. Okay, everybody knows if I contest in an election, the sure event is either I win or I lose. Okay, that's a sure event. Okay, now you know what I want to talk about now. I want to go into, there could be at times relationship between events or relationship between sets. Just like the same way that we normally have algebraic algebraic operation between two different variable or set or numbers. In your high school, you perform some algebraic operation like adding numbers together, subtracting numbers, multiplying numbers, and dividing numbers. Okay, when we're talking about events now, or talking about events, if A is an event, it contains element, and B is also an event, and we're interested in union, A union B union. The mathematical definition is that you are interested in element that belongs to event A or belong to event B. Okay, I needed to pay attention to or, that OR. Okay, that very conjunction is very, very crucial when we're talking about union. Now, the union is just going to be everything between them, everything between them. That is why it is shaded. You can see the whole of this is A and the whole of this is B. Everything has to be shaded. That's what we mean by union. Okay, now I'm going to go into another operation that we call interception. Oh my God, you want to be my friend, we need to have something in common before you can be my friend. Okay, now this is where they have in common. And that is interception. And you need to pay attention to conjunction, hand. Okay, A-N-D. Okay, so take a look at that. Okay, now the next thing that I want to talk about is the complement. Complement. Whenever you hear complement, something should come to your mind. Not if I'm interested in A, then anything outside A is the complement of A. It means I'm interested in this, not interested in that. And A and A complement, they actually constitute the sample space. And they are also mutually exclusive. What do I mean by mutually exclusive? It's either I'm here or I'm outside. That's what we mean by mutually exclusive. Okay, it's like being in this class and being in another class, and at the same time, that is not going to be possible. So the event of being in this class has prevented you from being in another class. Okay, so that is what we mean by complement of that. Okay, now I want to give you the definition of probability mathematically. If A is an event and S is the sample space, okay, then the ratio, okay, of the cardinality of A to the cardinality of the sample space is what we call probability of an event. So which is more or less like the ratio of required outcome to the possible outcome. I'm going to say that again. The ratio of required outcome to the possible outcome. That is what we mean by probability. Okay. The other time when we're talking about data gathering, and I said one of the way to one of the studies, okay, we have between choosing observational study and experimental study. And because of the ethical issues and some other reasons, we normally go for observation. With the observation study, we conduct survey or we make use of historical data. Let's say we conduct survey. This is a result of survey. Okay. This actually cuts across majors in the university. We consider math, business, economics, and others. And we also consider another categorical variable, Excel skill level. Okay, none, low, medium, and high. And what you see right now, okay, we got six students that are majorly maths, 13 in business, and so on like that. And of course, the number of 0 actually means there is no student among those who are major in maths that do not have Excel skill. Just take a look at this. We can ask probability questions here. Why? Why is it that we can ask probability questions here? Because there's a variation here. Variation. If there's no variation, there's no probability. Does that make sense? Okay. Now, let's say I want to answer a question now. I want to answer a question, but before I'm going to answer the question. Okay. Let me quickly take you back here. Here. The probability of this plus probability of this must equal to the probability of the sample space. And we call sample space a sure event, right? What is the probability of a sure event? 1. And that is the reason why the probability, okay, that is the reason here that I said the probability of A plus probability of A complement, okay, it's actually equal to 1. And if I know probability of A, I can find probability of A complement. If I know probability of A complement, I can find probability of A. Okay. Now, let us answer a question. The probability that a student in this class is not economics major. Okay. The probability that a student in the class is not an economics major. Now, I'm actually going to go back to the table. Not economic major. What I'm going to do is this. If I want to use the law of complement, I need you to pay attention. Okay. Okay. Now, our four of us look at the economics major. You know what I want to, what am I looking for? Not economic major. Not economic major. If economic major is A, not economic major is a complement of A. So what I'm going to do now, I will first find the probability of economic major. So the probability of economic major is going to be 24 divided by 46. Okay? 24 divided by 46. That is the probability of economic major. So if I know the probability of economic major, I can find the probability of not economic major, which is just going to be 1 minus that probability. Okay? Which is going to be 1 minus that. And that is what I'm doing here. Do you see that? The moment I know the probability of events, then not that event is a complement. All what I'm just going to do is to subtract it from 1. Now, the same thing applicable to probability. If you take a look at the question here, the probability of not Excel's, Excel skills not I. Oh, Excel skills not I. Our four of us consider high. Okay, because it said not high. Our four of us consider high. Okay, the probability of I is going to be the column total divided by the sample space. Our four of us get that. The probability of I is 6/46. The probability of not that now will be 1 minus that. Okay, so which is what I actually have here. Okay, that's what I have. Okay, now in summary, when you are working with union, pay attention to conjunction OR. When you are working with intersection, pay attention to conjunction A and D. When you are working with a complement, pay attention to knots. Does that make sense? Okay, now I want to go to this. We're getting there. I'm not going to scare you. It's easy. All what I need you to do, pay attention. Now, we actually want to touch down in a mathematical arena. Now, why do we need it? Because in a probabilistic world, okay, we need to leave that word mathematically. If there's no probability, there's no mathematics. Sorry, let me start from here. If there's no variations, no probability. No probability, no statistics, no mathematics. Nothing to manipulate. Okay, now let's take a look at this. We have event A. Okay, we have event A, and we have an empty event, empty set. If A has some elements, but that phi, an empty set, does not have an element, I want to perform a union between them. I want to add them all. I'm still going to have event A. Does that make sense? I'm still going to have event A. Now let's go to 2. I want to look at the intersection between event A and emptiness. Okay. What are they going to have in common? It's also going to be empty. I don't expect something that have, a set with elements and the one without elements. I don't expect them to have something in common. What they're going to have in common is emptiness. That's why you see a phi. Does that make sense? Okay. Now, when you come to number 3, the union between event A and a sample space. Okay, let's say event A is the state of Minnesota and sample space is the United States. If I add Minnesota to United States, it will give me United States. And that's why you see A union S equal to S. Let me tell you this. When I'm learning maths, when I'm learning anything that have mathematical equation, oh my God, I normally cite example within me. When you want to learn it, you need to have a practical mind. If you're just looking at notation, just like that, you may not be able to understand that. And that's why at times when we twist question in probability, we're actually going to get some student off their feet. We don't want that to happen. Now, let us now see A intercept S. For this to make sense to me, I'm going to say what is common between the state of Minnesota and the United States. Because this as an event is a subset of a sample space. So Minnesota and United States, what is common? Minnesota. Minnesota is common. Another example, use this class. This class and University of Minnesota. This class is going to be common. It's going to be, so that is why we got that. Okay, now when you have that, we're going to move right now. We want to talk about mutually exclusive events. Let me tell you this. We have different types of events. For you to be able to understand how to compute probability, you need to be able to identify what type of events do we have in the question. And because of that, I want to go into types of events. Number one, mutually exclusive events. What do I mean by that? When I have event A and B, okay, they are said to be mutually exclusive if they cannot occur together. They got nothing in common. That's what we mean. And that is actually going to be intersection. So A intersection B, then because they do not have anything in common, then it's going to be equal to 5, which is empty. And this is the picture. You can see now they are disjoints. Does that make sense? Okay. Now I need you to pay attention now. If they don't have something in common, then what is their probability? Then the probability will be 0 because they got nothing in common. And that was why I said the probability of A intersection B will be equal to 0. Now, there's another thing. If I now want to find the probability of the union, I know the probability of A intersection B equal to 0 because they are mutually exclusive. But what about the probability of A union B? Now, let me tell you this. When A and B are mutually exclusive, which means, okay, it's either one occur or the other one occur, then OR, attraction rule in probability. I'm going to say that again. When A and B, when events A and B are mutually exclusive, okay, then the union of them, the probability of the union of the two events that are mutually exclusive, that will attract addition rule in probability. I told you the other time, the type of rule to use in probability depends on the type of event. So if you are talking about mutually exclusive events, then A union B is always going to be probability of A plus probability of B. That is exclusive for mutually exclusive events. Does that make sense? Okay. Now, I want to go into probability axioms. What do we mean by that? Oh, we need rules. What are the rules that guide probability? Okay, if I want to use probability, then I need some rules. Okay, so students actually struggle with probability because of the fact that they actually, they don't really understand the rules. Somebody will struggle in Minnesota or in a state in the United States if you don't understand the rules. If you don't understand the rule of the state, you get into a problem. And that's, if you don't understand the rules that guide probability, then you are likely going to get into a problem calculating probability. Now, what are the rules? I need you to pay attention. Number one, I need you to see this. If I have an event E and a sample space X, and event E is a subset of the sample space, okay, then the probability of event E has to be greater or equal to 0. It's either it is 0 or greater than 0. Now, the question now is, if it is greater than 0, what is the highest number? The highest number is 1. Because of, and that was the reason, how do we know the highest number is going to be 1? If you look at rule number 2, the probability of a sample space is equal to 1. You can't go beyond 1. When you calculate your probability and you get a result that is more than 1, you are wrong. If you get a result that is less than 0, then you're also wrong. So you should have a way to check. So it should be between 0 and 1. When probability equal to 0 exactly, okay, that's an extreme. When it is equal to 1 exactly, that's an extreme. We call that's a perfect extreme, you know. But in a stochastic environment, in a probability space, we expect that probability should be greater than 0, but less than 1. Let me tell you this, because I'm going to stop here. We're going to continue from here. But before I go, if you have an Anthony, maybe somebody have a case, and your Anthony said you have 100% of winning, change your Anthony, because you don't have 100% of winning in a stochastic world, even if you have overwhelming evidence, because the judge could be infallible. The judge could take a decision that doesn't, because human being, he has, there's a limit to the capacity of his brain. The fact that he's human being, he can actually make a wrong decision. So, and that is the reason why the probability in a realistic world should be greater than 0, but less than 1. But that doesn't mean we can't get equal to 0, we can't get equal to 1. I just wanted to know that equal to 0, you're talking about perfect certainty. About certainty. It's like you're talking about deterministic situation. But what we normally have, I think I'm talking too much. I'm going to stop here now. We don't want to rush you. We're going to continue on Friday. Is there any question? Okay, so if you have questions, you can call. Make sure you all stay safe and have a lovely day.